Halogens. Halogens, like fluorine, chlorine, bromine, and iodine, are nonmetals. They're highly reactive and toxic. The reactivity decreases from fluorine to iodine. The reactivity of fluorine differs from the rest of the halogens due to its high electronegativity and small size. Astatine is radioactive in the group. In the elemental state, all halogens are diatomic. Chlorine and its compounds will be the focus of this discussion. Chlorine is prepared industrially by the electrolysis of molten sodium chloride or from aqueous sodium chloride brine via chlor-alkali process. Mercury cell and diaphragm cell are the two commonly used cells for the electrolysis of aqueous sodium chloride. The reaction in each of the above cells is as below. The reaction produces two useful products, chlorine gas and sodium hydroxide. The cells are designed to separate the chlorine gas, sodium hydroxide, and the hydrogen gas. The following explosive side reaction can then be prevented. 2NaOH plus chlorine gas produces NaOCl aqueous, NaCl aqueous, and liquid water. H2O gas and Cl2 producing HCl gas. The cathode is liquid mercury. The anode is made of graphite. Brine is continuously pumped into the cell. The chlorine produced is very pure. The diaphragm cell has an asbestos partition which permits the ions permeable, but not for hydrogen and chlorine gas. Periodically, fresh brine is added and NaOH is run off from the cell as well. The diaphragm cell has no pollution problems. The mercury cell has created some mercury contamination even after recycling the amalgam. Hydrogen chloride. The halides can be classified into two categories: ionic alkali and alkaline earth halides, and covalent nonmetallic halides. Hydrogen halides are an important class of halogen compounds. They can be prepared by the direct combination of the elements. So we have hydrogen gas, any halogen gas, to produce HX, where X stands for any halogen. Industrial HCl is produced as a byproduct in the manufacture of chlorinated hydrocarbon. So a hydrocarbon, C2H6, plus chlorine gas produces C2H5Cl, a chlorinated hydrocarbon, and the byproduct, HCl. In the lab, HCl can be prepared by the reaction of metal halides with concentrated sulfuric acid. So calcium fluoride or sodium chloride with sulfuric acid produces an aqueous sulfate and HF or HCl. HF is used as an etching reagent for glass surfaces, and for the same reason it is stored in plastic bottles. Uses of halogens. Applications of halogens and their compounds are widespread in industry and healthcare. Fluorides are added in small quantities to drinking water to avoid dental damage. Uranium hexafluoride is essential for isotope separation of uranium. Fluorine is also widely used for high-temperature coating polymers such as Teflon. Chlorine has an important biological role in the human body. It is the principal component in cell transport in intracellular and extracellular fluids. It is widely used as an industrial bleaching agent in textiles and paper. Chlorine is used to purify water and disinfect swimming pools. Chlorine is used for making several organic solvents, such as carbon tetrachloride, chloroform, etc. Large quantities of chlorine is used for making insecticides, such as DDT. It is used for making polymers, such as PVC. Bromine is used for making ethylene bromide, which is used as a scavenger for lead on gasoline engines. Bromine combines with silver to form silver bromide and is used in photographic films. Iodine is used for making tincture of iodine, which is a 50% by mass of an alcohol solution of iodine. It is used as an antiseptic solution. Iodine is an essential constituent in the hormone thyroxine. Iodized salt is 0.01% potassium or sodium iodide and will provide the necessary amount of iodine for the human body. Silver iodide is used for cloud seeding.